Okay, let's continue with our partial fraction decomposition. Right now we're going to look at how to decompose fractions that have repeating linear factors. Okay, so in other words, we have a factor of, for example, ax plus b, and that one has a power on it. So in other words, it's repeated. Here it would be repeated twice or repeated 3 times. When we have a repeating linear factor, then we have to have a decomposition term for each power of the factor. For example, if I had a power of 4 on my factor, I'd need a power of 1, a power of 2, a power of 3, and a power of 4 in my decomposition terms. Okay, this would be an example here. Let's decompose this rational function right here. Okay, and the first thing I need to do is factor my denominator. And when I do that, I see that I have a factor here of x minus 2. That's a non-repeating linear factor. And I have a factor of x plus 1 squared, quantity squared. This is a repeated linear factor. Okay, so I'm going to have decomposition terms of this form. Here's the single non-repeated linear factor, and here is the power of 1 and the power of 2, both of which are necessary for the repeated linear factor. Okay, and we're going to do the same thing that we did in the example with repeated or non-repeating linear factors. And I'm going to rewrite this equation here, but multiply both sides of this equation by this denominator here and here. Okay, and on this side, this will simply cancel out with the denominator, and I simply get this numerator here on this side of the equation. And on this side of the equation, I have to distribute these factors into this parentheses here, this quantity, and I'm going to get, when I distribute it in over here, the x minus 2 will cancel with that x minus 2, and I'm going to get a times the quantity x plus 1 squared. When I distribute it to this term, the x plus 1 here will cancel with one of these x plus 1 terms, and I'm going to get this. And when I distribute this to this term, the x plus 1 quantity squared will cancel, and I get c times x minus 2. Distributing in, and I'm going to get this. And now I need to make my coefficient of x squared equal to the coefficient of x squared that I have over here, which is going to be a plus b. So 5 is equal to a plus b. The coefficient of x has to equal what I have for coefficient of x here, so I have 2a minus b plus c. Okay, so 3 is going to equal 2a minus b plus c, and the 1, the constant here, is going to equal what I have for constants here, which is simply a minus 2c. I'm sorry, plus 2b, minus 2b, forgot the minus 2b. So this 1 equals a minus 2b minus 2c. And these are 3 equations now in 3 variables, and I can see that I now have my system of equations, 3 equations in 3 variables. I can make a matrix out of that. Each row is an equation. Each column is, these are the coefficients of a, b, and c, and these are the constants. Plug that into my calculator and use the reduced row echelon form of the matrix math menu, and I get my reduced row echelon form. This tells me that a is equal to 3, b is equal to 2, and c is equal to negative 1. And therefore, I can write my original rational function as this partial fraction decomposition. And note that if I were to add all 3 of these fractions back together, I would get this function back again.